What is object-oriented programming, OOP? Object-oriented programming, OOP, is a programming paradigm that organizes software design around objects rather than functions or logic. An object is a self-contained entity that contains both data and methods, which can be used to manipulate that data. OOP is based on the concept of objects, which can be real-world entities or abstract concepts. For example, consider a car. In OOP, a car can be represented as an object that has attributes like color, model, and speed data, and can perform actions like start, stop, and accelerate methods. This approach to programming closely mirrors how we think about real-world objects, making it easier to understand and manage complex software systems. Key concepts in object-oriented programming. Classes and objects. A class is like a blueprint for creating objects. It defines the properties and behaviors that objects created from the class will have. For example, a car class might define attributes like color and speed, and methods like start and stop. An object is an instance of a class. When you create an object, you're creating a specific example of a class. For instance, if you have a car class, you could create an object called myCar that is a specific car with its own unique color and speed. Encapsulation. Encapsulation is the concept of bundling the data, attributes, and the methods, functions that operate on the data into a single unit or class. It also involves restricting access to certain details of an object, which means that the internal workings of the object are hidden from the outside world. This is done using access modifiers like private, protected, and public. For example, if you have a bank account class, the balance of the account can be private so that it cannot be changed directly from outside the class. Instead, it can only be modified through methods like deposit or withdraw. Inheritance. Inheritance allows a new class to inherit properties and methods from an existing class. The new class, called a subclass or child class, inherits attributes and behaviors from the parent class or superclass. Inheritance promotes code reuse and logical hierarchy. For instance, you might have a general vehicle class with attributes like wheels and methods like move. A car class could inherit from the vehicle class, adding specific attributes like doors or engine type, while still retaining the properties of vehicle. Polymorphism. Polymorphism means many forms and refers to the ability of different classes to be treated as instances of the same class through a common interface. This can be achieved through method overriding or method overloading. For example, imagine you have a shape class with a method called draw. You can create subclasses like circle and rectangle that override the draw method to provide their own specific implementations. When you call draw on a shape object, the correct method for the specific shape is executed. Abstraction. Abstraction is the concept of hiding complex implementation details and showing only the essential features of an object. It allows you to focus on what an object does rather than how it does it. For example, when you use a smartphone, you interact with the user interface without worrying about the complex processes happening inside the device. Similarly, in OOP, you can interact with an object without knowing the details of its internal implementation. Real-life use cases of object-oriented programming. Banking systems. In banking systems, OOP is widely used to represent various entities like accounts, customers, and transactions. For example, a bank account class can have attributes like account number and balance, and methods like deposit and withdraw. Different types of accounts, such as savings account and checking account, can inherit from the bank account class and implement additional specific features. E-commerce platforms. E-commerce platforms use OOP to manage products, orders, customers, and more. For instance, a product class can have attributes like name, price, and category, and methods to add to cart or calculate discounts. Different types of products, like electronics and clothing, can be subclasses that inherit from the product class and have additional attributes like warranty or size. Game development. In game development, OOP is used to model game elements like characters, weapons, and scenes. A character class might have attributes like health, strength, and speed, and methods like attack and defend. Different types of characters, such as warrior or mage, can inherit from the character class and have unique abilities. Benefits of object oriented programming. OOP offers several benefits. Modularity. The code is organized into classes, making it easier to manage and maintain. Reusability. Inheritance allows for code reuse, reducing redundancy. Flexibility. Polymorphism allows for flexibility in how objects are used, making the code more adaptable to change. Maintainability. Encapsulation ensures that objects control their own data, leading to better data integrity and security. Conclusion. Object-oriented programming is a powerful paradigm that mirrors the real world, making it intuitive and effective for building complex software systems. By organizing code into objects, OOP promotes better design, easier maintenance, and greater flexibility, which are crucial for modern software development. Whether you're building a banking system, an e-commerce platform, or a game, OOP provides the tools you need to create robust, scalable, and maintainable software.